Hello, Maurieo. In this video I'm going to give a really basic introduction to the total station and its capabilities as to what it can do. So here's my little diagram of the total station. Unfortunately I don't have the ability to draw things in 3D so well, but here it is nonetheless. So here we have a total station here, usually set up over a mark of some sort, and it's measuring to a prism pole here, or pointing to a prism pole here. Now total station essentially does three things, or measures three things: horizontal angles, vertical angles, and slope distance. So vertical angles I'll talk about in a minute. Horizontal angles, so these are usually sometimes referred to as, we talk about bearings, but horizontal angles are usually measured in the horizontal plane, and they're measured from 0 clockwise, from 0 to 360. So the total station can measure the horizontal angle, or horizontal angles between marks. Vertical angles, it can measure vertical angles. These are angles, essentially up and down angles. Now most total stations measure their vertical angles as zenith angles. They measure them from the zenith, which is immediately or vertically above the instrument, is given the value 0. So when they bring the telescope down through 90 degrees and give a horizontal line, that has a value of 90 degrees, 0 minutes and 0 seconds. And the third thing that the total station measures is the slope distance. The slope distance, just the distance from the instrument to the prism. And we say the slope distance because quite often these are not on the same plane. The prism might be above or below the instrument. So with those three basic things that it measures, the horizontal angle, the vertical angle, and the slope distance, it can calculate a number of the things we want. And it calculates them from that information. It can calculate the difference in height and display that directly. So we don't have to actually record the vertical angle, we can just record the difference in height between the instrument, total station, and the prism. Difference in height. And then it can take the slope distance and reduce that down to a horizontal distance, because all our distances that we measure are usually on the horizontal plane, on our plans, or on the pan of a bit of paper. So that's it. That's what the total station does. It measures horizontal angles, vertical angles, and slope distance, or distance. And with that information we are able to calculate, among a lot of other things, the difference in height between the total station and the point that it measures to, and the horizontal difference, a horizontal distance from the total station to the prism pole or target or whatever. So there you go. That's it for the total station. I'm just going to write in up here, because I realise that I've missed a few little bits. Just going to write up in here prism pole, prism. That's what the target thing that we measure to, and this here's the pole. And we have a little bubble here on the side that holds it vertically, just in there. Okay, so there you go, a basic introduction to the total station.